Hey guys, I hope that you guys had an amazing spring break. I know that, of course, we're still stuck in our houses, but I hope that you enjoyed the rest because I know that being pre-AP kids, uh, y'all's work level hasn't been the same as, our other students in our campus. And I just wanted to give you guys a shout out for all of you guys that are actually doing your work because you're taking the initiative. Now, I know that, that maybe not all your teachers are doing the online videos, but these online videos, sometimes in college, you're going to have classes like this. And it's good that some of you guys have the self-discipline to, make the right decisions and still continue learning, even though, I mean, um, you could just be doing other things to get the grade. But I just want to say thank you for trying. Now, let's go ahead and get started with today's lesson. I am not going to show my face today because I am actually in my car trying to videotape this of the notes without any noise in the background, and the reason for that is because today is a little bit tough. There's a lot of stuff that we're going to cover today, but the topic today is solving polynomial equations. Now remember that whenever we are solving, let's hope this is working. Whenever we are solving, essentially what we're doing with these polynomial equations is we're finding the x-intercepts, our zeros, our roots. This is really what we're doing, okay? So today we're going to be talking about factoring and how we can use a quadratic formula as well in order to solve polynomials by hand. Now you guys can check your answers before you put them into Pearson by graphing on Desmos and finding your x-intercepts. Now for the problems that say factoring, of course you can't do that. You're going to have to factor by hand. So let's talk about these techniques. Now, for quadratics, last semester and in the beginning of this semester, we talked about factoring quadratics, and we can kind of use the same techniques. We still have difference of squares. This one right here, this one isn't new. Factoring by grouping, that's not new. These two are review for you guys. What's new is the perfect square trinomials and the sum or difference of cubes. Now, these techniques, so let's basically, if I have a polynomial that looks like this, it tells me that I can factor it and rewrite it like this in its factors. So for example, if I'm trying to factor out x squared plus 10x plus 25, what's going to happen is that I need to check are my first term and my last term, are they square numbers? So here, I'm going to square root these two. Square root of x squared is x. Well, that's a square number, right? Because I end up with a rational number. Now here, square root of 25 is 5. Again, no fractions, no decimals. So these two conditions are met. Now, I do want to check the last one. The last one says that this term is 2ab. What that means is that if this right here, my first term is a now, and this is b, if I multiply x times 5, right? Let me write it out. 2 times x times 5. If I multiply this out, I should end up with this middle term. When I multiply this out, I do get 10x. So this right here is going to work for this problem. Now, the nice thing about this is that as long as I can determine that this is going to fit, right, that I can use this rule, I don't have to do much work after that. I know that my factors are going to be a plus b squared. So I'm going to have a, which is x. So x plus 5 plus b here squared. And this right here would be my answer whenever a question would ask me to factor it. Okay, now that is with a plus sign. I did want to point that out. The first one is a plus. Now, in the second rule that we have here, it's the same, but now I have a minus. Since I have a minus, my answer is going to have a minus as well. Okay, so now I'm going to do the same thing. Now, notice that my numbers are the same, so I know that the square root of x squared here is still x. So I know a is x, and here square root of 25 is 5, and I know b is 5. So now I can rewrite this as x minus 5 squared. Okay, so these again are called your perfect square trinomials there. Now, difference of squares we like. You've been doing this since Algebra 1. Take a look at this one. Now, this one has an error here. Let's turn this into a 16. Now, I have 4x squared minus 16. I'm sorry about that. So we're going to take the square root of each one, and I get 2x for square root of 4x squared. So this is my a. And then my b here is going to be the square root of 16, which is 4. Okay, so then we're going to use our rule. So my factors are my answer. Whoa. My factors or my answer are going to be in this style right here. Now I have a first, so I have 2x. And then I have plus b, so I have plus 4. And then I have a again for my next parenthesis, so 2x. And then minus b, so minus 4. Okay, and this is how we would factor this one. Now, factoring by grouping, you might have forgotten, it's been a while since we've done it, but basically it's what the name says. We're going to group our terms here. So here I have 4 terms. If I have a trinomial, I would have to find extend my middle term first before I can do factoring by grouping. So you do need 4 terms. So here we're going to group the first 2 terms and the last 2 terms. So I have x cubed plus 2x squared. And what I'm going to do is I'm going to find the GCF of each parenthesis. So here my GCF is x squared. So I have x plus 2. And then here my GCF seems to be -3. So I'm going to take out a -3. And then I'm left with x plus 2 in here. Remember that when I take out the GCF, really what I'm doing in order to get this inside the parenthesis here, all I do is divide by my GCF. So I divide by -3 here. -3x divided by -3 gives me x. -6 divided by -3 gives me 2. So now I have this right here. Remember that the goal is to have the same binomials. Now, since I know that these two are the same, I'm going to factor out the x plus 2. So I am taking out x plus 2, and I am left with x squared minus 3. So I have x squared minus 3. And this right here would be my answer. Okay. Now, another new one. So this is sum or differences of cubes. Now, essentially what's happening here is that I have 2 numbers that I'm adding in this case that are cube numbers. And in this case, 2 numbers that I'm subtracting that are cube numbers. So here, example 5, I have 8x cubed plus 1. So let's test it out. We're going to do the cube root of 8x cubed. Remember, the cube root just tells me what can I multiply 3 times so that I can get what's inside. So here, the cube root of 8 I know is 2. The cube root of x cubed is x. So the cube root of 8x cubed is 2x. And you can actually work it out backwards. So here on the side. 2x times 2x times 2x should give me 8x cubed. And it does, because I have 2 times 2 times 2, which is 8. Why I put it x squared? And then x times x times x, which is x cubed. Okay, so 2x is my cube root of 8x cubed. This right here works, so I know that this is my a for my rule there. And then I'm going to do the cube root of 1. I like the cube root of 1 because we know it's just 1. We multiply 1 3 times to get 1. So this right here is my b. I have a and b, so I'm ready. All I have to do is plug in my a and b into this right here. So I'm going to start writing this out. I have a plus b in the first parenthesis, so 2x plus 1. And then I have a squared, so 2x, this whole thing, a is squared, minus a times b. So I have 2x times 1 plus b squared, so I have plus 1 squared. Okay, now I know that some of you guys are like, why don't you just simplify? But I just wanted to show you guys the steps. So here I have 2x plus 1. Here, 2x squared. Now, whenever you're plugging in, make sure you use parentheses. I should have used parentheses here, and I should have used parentheses here. Parentheses help you keep on track. Now here I have 2x squared. If you just put 2x squared, that is wrong. You have to make sure that you're squaring the whole 2x. So this would be 2x times 2x. So I'll write it out here in the top so you guys see what I'm talking about. So 2x squared is equal to 2x times 2x. This right here is wrong. So 2x times 2x is 4x squared. And then here I have negative 2x minus 2x times 1. 2x times 1 is just 2x. And then here I have 1 squared, so plus 1. Okay, now this right here is my answer. Okay. Number 6 is very similar, but this time we have our minus sign here. So I'm subtracting this time. When I'm subtracting, my signs change. Okay, last one stays the same, but my first two signs are going to change in my answer. So here, again, I know a is still 2x and b is still 1. That does not change. So here I'm going to have a minus b. So a, which is 2x, minus b, which is 1, and then times a squared. So a squared is going to be, again, 4x squared, plus ab, which is going to be, again, 2x, plus b squared, which is 1. 1 squared is just 1. Okay, and this would be my answer for this one. So these are the techniques, or these are the types of factoring that we're going to do in our problems. Remember, this is just factoring. We haven't solved our polynomial. We haven't found x-intercepts yet. That's what we're going to start doing now. So in example 1, you're like, what were the other examples? Example 1 after the first 6 examples, guys. Okay, we're going to find the real or imaginary, whoa. Sorry about that. The real or imaginary solutions of the polynomial equation 2x cubed minus 5x squared is equal to 3x. Now here I have your steps for you. Now, I don't know if you remember or not, but your imaginary numbers are the ones that have the I in it, imaginary I. Okay, so we will have an example, which is not this one, but an example 2 that has an imaginary solution. Um, with the imaginary solutions, your x-intercepts won't show up on decimals. So if you try to just do all of these on decimals and it happens to be that you have an imaginary solution, you won't get the right answer, guys. You have to try this by hand. Some of them will work on decimals on Pearson, but not all of them. Okay, rewrite in the form of p of x equals 0. So here I have a polynomial, yes, but I have stuff on both sides. I need one side equal to 0, and I don't know about you guys, but I'm going to make this 3x equal to 0 because I want to do less work. So in order to make this side equal to 0, I'm going to have to subtract both sides by 3x. So here I have 2x cubed minus 5x squared minus 3x is equal to 0. Now I am ready to start factoring. Now again, we want to make our lives a little bit easier, so I'm always going to be trying to look for a GCF because now we're doing the fun stuff, the factoring, and I need a GCF. Always look at your term with the smallest exponent. So in this case, it's an x. I have 2x squared, because again, remember when I factor it, I divide each term by my GCF, which in this case is x. So 2x squared minus 5x minus 3. And all of this is equal to 0. Now, guys, we also want to check our numbers to see if I have any GCF, greatest common factor of my numbers, my coefficient, sorry. In this case, I don't. My GCF is 1, so I'm not going to write it out there. Now we want to factor. You can factor, you can still continue to factor this inside. And there are two different ways you can do that. You can either do factoring by grouping, or you can do the quadratic formula. And what I'm going to do is I'm going to do the factoring by grouping, but I'm also going to kind of remind you guys how to do the quadratic formula. So let's do the quadratic formula first because I'm not going to do it all the way out. And the reason for this is because it's just simplifying with the quadratic formula. So we're going to put right here, we're going to hit pause on this part, and we're going to try to just factor out this part. So do not forget that you still have an x in front of here. But let's go ahead and do this. So quadratic formula, remember, is x equals negative b plus or minus square root of b squared minus 4ac, oops, wrong one, all over 2a. I would sing this to you guys, the song to you guys, like I did in some of the classes back when we were at school, but I don't want y'all making fun of me and making TikToks on me, so I'm just gonna write it down for you guys here. Now, all you have to do is plug in your A, B, and C. So we need to identify A, B, and C. So 2, -5, -3. You plug this in here, and it's going to give you your x values, okay? Now, here, when you plug this in, it's going to give you your x values. It's going to give you your x-intercepts. Remember that these are going to be your x-intercepts. So whatever you get from here plus this right here. Remember that this x on the outside tells me that I have the x-intercept x equals 0. So this right here is how you could use a quadratic formula to solve this. But let's go ahead and do factoring by grouping because we need to practice this. Factoring by grouping is really important, especially for those of you guys who are planning to continue on the pre-AP math track. Okay, so whenever I'm factoring by grouping, what I need to do, whenever I'm factoring this right here, Now, notice that my leading coefficient is not 1 this time. We've been working with leading coefficients of 1. It's been easy, but now we have a 2. In order to find the two numbers that I need here, I need to multiply 2 times -3. 2 times -3 is -6. So I'm looking for two numbers whose product is -6, and the sum is still the same. The sum is still my middle term, -5. Okay, so I want two numbers that when I multiply them, I get -6, but when I add them, I get -5. So here, I have negative, let's see, negative 2, man, I had a brain fart. Okay, 6 and -1. So 6 times -1 is going to give me -6. And then when I add these two, I get 5. -6 and 1 will work. -6 times 1 is -6, and -6 plus 1 is -5. There we go. I just did this, so I don't understand what's going on with my brain, but okay. So now I have these two numbers, so now I can break down my middle term here. So I have 2x squared minus 6x plus x minus 3. Okay. The link here, the blue link, has the video that's on Pearson, like on your textbook, if you guys want to look at that, because I know that at this point you might get a little bit confused. Horrible teacher here, but you can also go on YouTube, and there's some links in the bottom for you guys too, but you can go on YouTube and search up factoring by grouping. Some of you guys might remember how to do this from earlier this year, and some of you guys might remember how to do it using the box method. Remember, you could also use the reverse box method. Miss E doesn't use the box method, so we're just gonna do it like this. Okay, so again, we're leaving the x out, but let's not forget it later on. Here, we're gonna actually factor by grouping. So I'm gonna group the first two terms, group the last two terms, kind of like how we did up here. And then we're just gonna find the GCF. So we just grouped, and then now we're gonna find the GCF. So GCF of 2x squared and -6x is gonna be 2x. So then I have x minus 3. GCF of x and -3 is just 1, so I'm gonna have 1 as my GCF. Okay, remember that you want your binomials to be the same, so here I have x minus 3. I'm gonna factor that out, and when I factor that out, I'm left with 2x plus 1. So this is how I would factor this quadratic right here. Now, remember that we have the x, so I'm gonna bring that x down because that goes in front there, and I'm gonna bring down my equals 0. Now, this is step 2. So all of this work was just step 2. Now we're going to use the zero product property. By now, you guys should have that engraved into your all's brains because we keep using it. Remember, zero product property and just make each factor equal to 0. So I'm going to make this x equal to 0. Well, that's a 0. I don't have to do much work with that. That was nice. And then I make x minus 3 is equal to 0. Some of you guys just look at this and y'all can tell me x is going to be equal to 3. But for this one, when we make this one equal to 0, we have to be really careful because we have that 2 in the front there. So we want to actually work it out. Then we just solve for x. I'm going to do minus 1 on both sides. So I get 2x is equal to negative 1. Divide by 2. So I get x is equal to negative 1/2. So how many x-intercepts do I have here? I have 3. X equals 0, x equals 3, x equals negative 1/2. I do not have any imaginary solutions in this example. I don't have any i's, so there are all real solutions. Okay, and again, you can do this using the quadratic formula. When you use the quadratic formula, you should get x equals 3 and x equals negative 1/2 as your two answers. So if you guys want to do the quadratic formula instead of remembering all these steps, you can. So let's go ahead and move on with example 2. Here we're going to be again solving another polynomial equation. This time we have x to the power 4 minus 3x squared is equal to 4. First step, let's write it down. It's already there, so I'm going to leave it there. And now we're going to rewrite it in the form of p of x is equal to 0. Just make one side equal to 0, guys. We've been doing this. Y'all can do this. I believe in y'all. Y'all are super smart. I'm pretty sure y'all be awesome at this. So x to the power of 4 minus 3x squared minus 4 is equal to 0. I subtracted that 4 to get it to the other side there. Okay, so we did that. Now we want to write in terms of x squared. Okay, sorry guys. So I was looking at the example, and actually I wasn't going to be talking about this example today. We've been covering this lesson is a lot just in itself, and this I taught it last year and it confused a lot of my students, and it was me being in the classroom. So I'm not going to go over this example. You don't need it for the Pearson. um, I want you guys to practice the new stuff first before we can start moving on there. So now let's go ahead and do example 3, which is sum and difference of cubes. So here I'm going to factor out 3x to the power 4 minus 3x, and then I'm going to check my linear and quadratic factors. So this is new vocabulary for you guys. Linear factors are factors where you have where your factor is linear. And then quadratic factors is where your factor is quadratic. So for example, let's look at example 1. These were my, why is it not loading? Great. There we go. So my factors were x, x minus 3, and 2x plus 1, right? So these were my factors. Linear factors say that when I graph this factor, so if I happen to graph this on decimals, x minus 3 or x or 2x plus 1, would I get a line or would I get a quadratic? In these cases, for all three, if I graph this, I would get a line. So that's what it's asking for, if my factors are linear or quadratic factors. Okay, so here, I'm going to factor this out. And in order for myself to factor this out, I'm going to go ahead and try a GCF first. Remember, we want to try GCFs to make our lives a little bit easier. In this case, we have to do the GCF first in order to factor. My GCF of 3x to the power 4 and negative 3x is 3x. When I divide, I get 3x to the power 4 divided by 3x. And that's going to give me x cubed and then minus 1. Okay, so I have 3x times my binomial here. Now, I can continue to factor what's inside here. And the reason that this is going to work out nicely is because I have Meyer techniques up here. I know that I'm going to be using this one down here for part A because I have x cubed and 1, which are both cube numbers, and I'm subtracting these two. So I'm going to be using that. Now I'm going to do the cube root of x cubed and the cube root of 1. So I know that a here is going to be x and my b is going to be 1. So here, sorry, and this is only for this part right here, guys. Let's not forget the 3x. We're going to rewrite this using this side. So I have a minus b, which is x minus 1. And then I have x squared plus ab, which is just x. And then b squared, which is just 1 squared, which is 1. Okay. So now this part in here is this. And let's not forget about the 3x. So this is actually factored completely. This would be my answer. Now, let's talk about the linear and quadratic factors. For my linear factors, I would have 3x and x minus 1. Again, if I graph 3x, it's going to be a line. If I graph x minus 1, it's a line. And we know that if I graph x squared plus x plus 1, this is going to be quadratic. So this would be your quadratic factor. Okay, and I'm sorry about my computer. I think it's because I'm in the garage that my internet is so slow. Is it not gonna want to pop up? Cool. Okay, so let's go ahead and do part B. So for part B, this time we're gonna do addition here. So we're gonna use the top one now. I guess I'll color code this. Remember that we're gonna try to do a GCF first to make things easier on us. And we're gonna go ahead and do that. There we go. Okay, so GCF of x to the power 4 and x is x. So, and then GCF of 8 and 27. Can't think of anything. We don't have a GCF here. So we're gonna keep the 8. So I have 8x cubed. And then I have 27. Okay, now we're going to do the cube root of each one. Cube root of 8x cubed, cube root of 27. So I have 2x there because, again, remember from the beginning, 2x times 2x times 2x is going to give me 8x cubed. Cube root of 27 is going to be 3. And that's because 3 times 3 times 3 is 27. So I know that this is going to be 3. I have my A, I have my B. So now we're going to use our formula up here to rewrite this. A cubed plus B cubed is going to be equal to, I don't have to write that down. Y'all should be able to see it on the screen. Okay, So I have a plus b, so 2x plus 3. Esther. 2x plus 3, and then I have a squared, which is 2x squared, which again we remember is 4x squared. Okay, Esther. Okay. Thank you. 4x squared and then plus ab. At least she went into the room. I'm sorry about the interruptions, guys. This is not easy working from home. And then 2x times 3 is 6x, because here I have a b. Look at me messing up. I'm sorry. This is what happens when I'm so distracted. This right here should be minus. I'm sorry about that, guys. So far, all I'm doing is plugging in a and b to this up here. That's all it is. I have 4x squared minus 6x and then plus b squared. So I have 3 squared. So plus 3 squared, which is 9. Okay, so these are my factors. Now let's not forget our x over here because that one is part of our answer as well. So this is my, I am not going to try to box up. Let's not do that. This right here is my answer, or underline, ridiculous. My factors. Now linear and quadratic factors again. These are linear. And then this one is, today's not my day. And then this one is quadratic. Okay, one more example and we'll be done. I'm sorry about the interruptions, guys. I tried going to the garage when my computer was dying and the internet was not doing very well, so I had to come back inside. Example 4, factoring polynomials by grouping. So we've already talked about this. So if you guys want to go ahead and start doing your Pearson, you can. If you want to keep watching, that's good as well. Now, before I do example 4, I did want to scroll down and show you guys that we do have a lot of links here for some help if you're having trouble with anything. Please, please, please watch these if you need them. Remember that our office hours are Mondays and Wednesdays at 3:30 to 4:30. Okay. So let's go ahead and do this by grouping. So what I'm going to do here is I'm going to group my first 2 terms, and then I'm going to find the GCF. So we're here. So here I have GCF of x cubed and 3x squared is x squared. I end up with x plus 3. And then here, the GCF of negative 16x and negative 48 is negative 4. Sorry, 8. So here I have 2x oh no. GCF is negative 16. And then I have x plus 3 here. So then I'm going to go ahead and rewrite this as x plus 3. I'm factoring out the x plus 3. Then I have x squared minus 16. Now, Remember that we want to factor out completely. That's horrible. Underlining again, I'm sorry. So this is not factored completely, and the reason for that is because I can still keep factoring this right here. And what technique could we use from what we discussed earlier? Sorry. We can use difference of squares. Okay, so here I'm going to rewrite the x plus 3 so we don't lose it. Square root of x squared is x, square root of 16 is 4. So here I have x plus 4, x minus 4. And that's just using the rule that we have. And this is how you would factor this completely. Now, in this case, when we're talking about our linear and quadratic factors, they are all whoa, I can't write. They are all linear, not Leo, linear factors. Okay, you guys, that's it for today. Please make sure that you do your Pearson 8-4 solving polynomials. It is due by Friday night. And the reason that now the deadlines are going to be Friday night is because I have to make sure that I'm contacting your parents and you guys if you're not doing your work. So please, 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 please do your work on time.